So the notes from yesterday, I need you to focus. Do I need to move you? So where 10.1 was on the front, 10.2 is on the back, and then we'll continue. So you need both pieces of notes. Does anybody not have today's notes? I already handed you today's notes.
Today's? Oh, my gosh, you did. Thank you so much.
Do you have today's notes, Tatiana? You're good? Just checking. All right, so tell whether the line, ray, or segment is best described as a radius, chord, diameter, or secant, or tangent. Which one of these were segments?
R and E.
Okay, no, I mean which one of these words are segments?
Radius.
A radius is a segment. What else?
A diameter.
A diameter is a segment. And?
A secant.
No.
Radius. No, you already said that.
She's already said the answer is chord.
Chord.
A chord. A radius goes from the center to where?
Out to the rim.
Yeah, center to the rim. I say to edge. Rim is fine. Center to edge. Where does a diameter go?
Edge to edge.
Edge to edge. But what else? Through the center.
Center.
So the diameter's through the center. Where does a chord go? Edge to edge. Yeah. So are all chords diameters?
Yes.
No.
What?
All diameters are a chord, but not all chords are diameters.
You missed it. I remember you said.
That's good. So we're going to name each of these pieces, but those are the segments. The two types of lines were secants and tangents. How many times does a tangent touch the line or touch the circle? Secant? Just twice. Tangent, once. So it's just a refresher from yesterday. Letter A is PR. Is that a segment or a line?
That is definitely diameter.
Okay, I'm just asking is it a segment or a line? That's a segment. So that means it's one of the top three options, a radius, diameter, or chord. So we're going to look. Goes from P to R. Edge to edge through the center. That is indeed the diameter. Letter B has the arrows. So MN, which is a line. How many times does MN touch circle? Once, which makes it tangent. PQ is also a line. How many times does PQ touch circle? Twice, which makes it a secant.
Dang.
And then QO is a segment because of this line above. QO, which would be a radius. All right, some of the other things we learned were about number 6 and number 8. Number 6 is DE tangent to circle C. I need you to put a star next to this one. This one will be on the quiz, and a lot of people get it wrong the first time. And I don't want you to be one of them. So, if a line is tangent, the tangent line and another line have to be perpendicular. What line was the second line? In order for a line to be tangent, the tangent and the radius have to form 90. I would write that down if you don't remember it. So in order for a line to be tangent, the tangent and the radius have to form 90. So which one of these is the tangent line in question? DE. How do you know that? The question literally says it. I know. That sounds like a dumb question, but people still don't know. Which one of these is the radius? CD. So in order for this to be a tangent line, it has to form a right angle between these two. So what shape would this make?
Triangle.
What kind of triangle? So we need to see if this is a right triangle. Before we do, okay, we normally use the Pythagorean theorem. Which of these sides would be the hypotenuse? CE. Right? CE. So you're both wrong.
Nice.
CE. So you were more on track. But 2 is only this piece. It's not the whole line. What is the measure from the center to the edge? Center to the edge.
3.
It's going to be 3. Why?
Because the radius is the same.
Because it's the radius. Center to edge is the radius. So what's the length of the entire hypotenuse? 5. So because of this, we're going to do a squared plus b squared equals c squared. What are the two legs going to be? 3 squared and 4 squared. And then what will c be? 5 squared. Didn't I tell y'all this is the most common Pythagorean triple? 3, 4, 5. What's 3 squared? 9. 16 squared? Sorry, 14 squared?
16.
Whatever. 5 squared is 25. What's 9 plus 16? Does 25 equal 25? Yes. So this would be a yes. All right, number 8, points M and N are points of tangency. Find the values of x. So when two tangents come together at one point, what do we know about the two tangents? They're definitely not perpendicular. They're what? They're congruent. Perpendicular intersect and form 90, but there are no 90-degree angles here. So they're congruent to each other. So what do I do to solve for x? Set them equal. But here is the problem. How many answers am I going to have? 2 of them. If you're in Algebra 2 and you don't know this yet, however many the highest exponent is, that's how many answers you have. So the highest exponent is a 2. You'll have 2 answers. So the square root of 9, most people know is positive 3, but it's also negative 3. So you'll have 2 answers. You what? You'll be okay. Because if I plugged in negative 3, what's negative 3 squared? Positive 9. And if I plugged in positive 3 squared is still positive 9. All right, so now we move into 10.2. So here's what we're going to be talking about today. We're going to be talking about arcs of a circle. So we're still on the notes we were before. We haven't gotten to central angle. But what's going to happen? An arc is a piece of the circle. The arc is the measurement in degrees. So we'll talk about it. Okay? The first one we're going to talk about is a central angle. A central angle is an angle whose vertex is the center of the circle. So a central angle, which is the first blank, an angle whose vertex is the center of the circle. And then I would just draw the picture so you can see. Once you have drawn it, we're officially on the second set of notes. We're going to talk about all the types of angles. So make sure you draw it on this picture. There are 2 types of arcs, technically 3 types of arcs. One of them is a major arc, and the second is a minor arc. A major arc, which is at the top of your notes, a major arc is part of the circle that measures between 180 and 360. At this point, you'll probably want a highlighter. A minor arc is part of a circle that measures less than 180. All right, so if you take out that highlighter, we're going to talk about the major arc first. So a major arc in this picture, my outline's not going to be great, but I've outlined it in red. You name a major arc with 3 letters and an arc above. Okay, so you name it with the 3 letters, starting with one of the endpoints of the arc. So you would start at A, go towards D, end at B. So ADB. You could also name it BDA. You do need to know how to name these. So this was a major arc. Hopefully you've highlighted it on your paper. So ADB or BDA.
D always has to be.
In this picture, yes, because that's the direction you go in. If you said ABD, ABD, you would have said this one. Does that make sense? And then C will never be mentioned because it's not a part of the arcs. A minor arc you name with 2 letters. Yes, dear. We're on the new set of notes. Did you grab the new set of notes? Okay. They're on the table. A minor arc is less than 180, so this would be our minor arc. You name it with 2 letters. So you would have the arc symbol, and then you'd say AB. Or you do the arc symbol and say BA. These are two types. Make sure you put the arc above or you're not naming an arc. Good. Last one is called a semicircle. A semicircle is an arc whose endpoints are the endpoints of the diameter. And it measures 180 degrees. So a semicircle is an arc whose endpoints are the endpoints of the diameter, and it measures 180 degrees. A semicircle is half the circle. How many degrees fit inside of a total circle? 360. So half of 360 would be 180. And you'll want to draw on your picture. So then you draw the picture.
Talking to me?
Yeah. And the picture's on screen. All right, we're going to name the top of the circle. I'm going to highlight it. It's a red. You still name it with 3 letters. So what 3 letters would we use? What was that, Peyton? ACB. What could we also name it? BCA. And then if I wanted to name the bottom of the circle, this would be ADB, or it would be BDA. All right, and how many degrees is a semicircle? 180. Good. So this is not on your notes. We're just going to talk about it. The measure of a minor arc is the measure of its central angle. So what that means, pick a number between 1 and 90.
2.
27.
Y'all are dumb. Okay, 27 is fine. You picked the smallest number. Look at this angle.
He chose 90, I chose 2.
2 degrees is like this.
Okay.
It's closer to 90 than it is 2 degrees.
But 90 looks like
90 looks like a corner.
this. It looks like this.
Yeah, it's just tilted.
That is a very...
It's about 87 degrees, so, I mean,
How you gonna
how am I going to prove it? Because it comes from your book.
prove it?
Whatever. All right, anyway, so the measure of the central angle, remember, a central angle has a vertex on the center, so it'll be the same. So the measure of AB would be 27. That's it. That's the answer. The measure of the minor arc. How would we name this minor arc, the one that we just highlighted? AB with an arc above would be 27 degrees. Yes, that's it. To find a major arc, you can do a couple different things. The major arc here, what would we name it?
AFB?
AFB. If this piece was 27, we know an entire circle is 360. How would we find the rest of the circle if part of it is 27? Subtract it. So you would take 360, subtract 27, and you get a number. Is that 333? We just gonna trust me?
Sure.
I don't trust.
So break out the calculator. All right, so here we go. Find the measure of each arc of circle P, where RT is the diameter. So the first one, RS, is that a major or a minor arc?
I got you. It's a minor.
It's minor because it's 2 letters. So you start at R and go directly to S. So we're going to go up or down around the circle.
Around the circle.
Yes, but up or down? Down. Towards letter S. How many degrees is RS going to be? 110. The same as its central angle. So 110 degrees. Next one we got RTS. So starting at R, we go around the circle towards T. So that would be up towards T and at the letter S. So remember, the entire circle is 360 degrees. How much of the 360 is not included? 110. So subtract it till we get 250. All right, and the last, RST. So it starts at R, goes towards letter S, and ends at T.
That looks like half, Miss Marshall.
It definitely does. It starts and stops on the diameter because the diameter is RT. So how many degrees is this? 180. It's a semicircle. So it doesn't ask, but what would the measure of TS have been? You will need to know how to find it. 70. How many degrees is from part of the diameter to part of the diameter? 180. So if total it's 180, you already have 110 of it. That means 180 minus 110 is 70. We all comprehend that? Okay. You can add 2 arcs together. So if they're right next to each other, adjacent means right next door. So if this arc was 20 and the arc right next door was 30, if we need to find EAB, we would add 20 and 30, which would make 50. Okay, so that being said, we are on the second page. Find the measure of each. Letter A is GE. Is this a major or a minor arc? Minor. We go from G directly to E. So are we going to go left or right around the circle? Right around the circle. Towards E. The other way would have given you a major number, not a minor number. So we add 40 and 80, which make 120. Which is the answer to that. Then we do GEF. From G, we go towards E. And then we end at F. So you add all of those. 40 and 80 and, 110. So what do we get? 230. Then last, we're looking for GF. All right, so think about, you could do this one of 2 ways.
Add it up and then
Subtract
it
from 360. What was the measure of GEF? We already found that. 230. So 360 minus 230.
130 degrees.
Yep. Good.
Thank you for teaching me, Miss Marshall.
Anytime.
Degrees something.
It's okay.
You sure?
Do I ever mark it off when you forget it? I never do.
They used to.
I literally never do. A recent survey asked teenagers whether they would rather meet a famous musician, athlete, actor, inventor, or other person. The circle graph shows the results. Find the indicated arc measures. I asked earlier people who they wanted to meet, and I had no idea who they were talking about. Who would you?
John Mess,
Nope.
John Wood.
singer for Dance Gavin Dance.
Nope.
Hey,
Nobody knows.
Anybody else?
Oh, Dwayne The Rock Johnson.
Michaela
He's a-
Mulkey.
I agree with that.
what about Anthony?
Michaela Mulkey.
Is that the
Leonardo
She plays for
DiCaprio.
the Olympics. She's on
gymnast?
the softball
Tom
Olympic team.
Cruise?
softball? What is
Leonardo da Vinci.
Tom Cruise? He's probably weird.
He runs with it.
I'm just saying.
It's probably
I don't
super
even
weird.
know what
Splinter from the Ninja Turtles. He's really cool.
You're dumb. I'm sure if you go to Disney, you could meet him. Or Universal. Universal also.
You're done.
No, not you.
One
Marcus
Epcot. I'm going. Just throwing it out there.
I don't
Steve
watch.
Carell.
Steve Carell.
I wanna meet him.
Oh no, he watched.
All right, here we go. So you have a pie chart, and it already tells you the degrees. Someone will need a calculator because we'll be adding a lot. We're going to find AC. So AC is a minor arc. So are we going to go left around the circle or right around the circle? Left. You go the shortest distance. So then it would be 29 plus 108, which is?
137.
Good. 137. Letter B, we find A, C, D. So start at the letter A, go towards the letter C, and the letter D. You can add them all up. What is 29, 108, I know, plus 83? What do we get?
What?
It's 220.
But you won't. Okay, you just call me.
I did.
But now I'm a kid.
She's not. She's trying math.
I
What are
tried
you
math.
doing?
I tried math too.
Whatever.
I get it
ADC.
all. You know.
ADC. So you can do this one of two ways. You can add 79, 61, and 83. Or you could subtract 29 and 108 from 360. Either way, you get the same answer. Sure. So 83, 61, 79. What do we get?
137 minus 360.
Yes, which would be,
200 something.
Yeah, 2023.
yeah.
3.
Well, I was adding the end. All right, then we have EBD. EBD. So from
that doesn't work.
E towards B, end at D. Yes, it does.
I thought you were gonna like.
So take 360 and subtract 61. We get 299. Because 360 minus 60 is 300, and then minus one more. All right, we're almost done. We got two things. Okay, so flip the next page. This is our last page together. We're going to talk about congruent circles. So here's what I want you to write down. Congruent circles have the same radius. So they have the same radius. We're on the next page.
Oh, yeah.
They have the same radius. That's
Oh,
it.
hey, Miss Marshall. You write cursive real good.
Can I write in cursive?
Like real good.
Yes. I could do calligraphy. Is what you're asking? Calligraphy?
That goes like that.
Well, yeah. Yes and no.
She's a painter.
Well, I think
That's, yeah.
It's something like it.
Anyways.
She's a model. I saw somebody else. Calm down.
Okay. So here's what I want you to know. In order for arcs to be congruent, they have to have the same radius and the same measure. So I want you to write down same radius, same measure. Same radius, same measure. Same radius, same measure. Because if you know, if it's the same circle, they have the same radius because it's the same circle. And if they're congruent circles, when are circles congruent?
When they're the same radius.
When they have the same radius. So congruent arcs going to have the same radius and the same measure. Okay? So we're going to decide through each of these. You have to go through like a checklist. Does it have the same radius? Does it have the same measure? So in the first, do they have the same radius? Yes, they do. It's the same circle. So within a circle, the radius is going to be the same. Do they have the same measure? Yes, they do. So are these two red arcs congruent? Yes. All right, we look at the next. Do these have the same radius?
Yes.
First one is QS, the second one QU. Do they have the same radius? No. So this would be a no. All right, last. Do these two have the same radius? How do I know they have the same radius?
You got a congruent.
The congruent mark. So yes, same radius. Do they have the same measure? Yes, they do. So this is a yes.